Hello, my name is Mark DeWitt. I'm a Teledyne LeCroy Field Applications Engineer. Today we're going to go through the operation of the T3 Arbitrary Waveform Generator, or I should just say the T3AWG. I'll be referring to this as the AWG from here on. This is the AWG on the bench in our Chestnut Ridge, New York demo lab. Here we've got a T3AWG6K, which is a 6.16 gigasample per second, two-channel AWG, two channels here. So we've got channel 1 connected to channel 1 on our oscilloscope, and channel 2 connected to channel 2 on our oscilloscope. For this video, we're going to be looking at the channel 2 and from the AWG and the channel 2 in the oscilloscope. So that lets us know what we have on the bench here. If we go to the AWG desktop, it's running Windows, and here we look at the Windows desktop. The UI that we see here, and I'll maximize this in just a moment, is the AT Simple AFG, or Arbitrary Function Generator. There are two other desktop icons, the AT True ARB, and then the AT Waveform Editor. In this video, we're just going to talk about the AFG Simple, or the AT Simple AFG. I'll maximize this, and then this is the user manual for the AT Simple AFG that we're going to be discussing today. You'll get this on the Teledyne LeCroy website. I'll give you more options. This is what's under those three buttons. Exit to the top left, full screen, bottom left is what we're after here. So we'll go full screen. That does that. And now this is set to generate a sine wave that is 100 megahertz, 1.2 volts peak to peak, 0 volts offset, 0 degrees phase. And here we are, 600 millivolts minus 600 millivolts. That gives us our 1 volt, our 1.2 volt peak to peak. The internal noise is off. The trigger is set to timer. And for our purposes, as we start here, we want to set the trigger to the button. We do that by going to Settings and to Trigger Settings. And there's our three choices for the trigger. The trigger in is an external trigger in. And then timer, but we're going to go with the trigger button for now. We'll come back to the timer. We'll use the timer later on. While we're here, there's the device settings here, which is some user interface settings. I haven't seen this have any effect. It's set to 0 right now. Clock settings. This is the internal clock, which we're using now at the internal reference. Can take an external clock in or a reference clock in. And it can also output a clock, which is turned off at the moment. Trigger settings here. Marker settings are here, and this just sends out a marker that is synchronized to the waveform that we're generating, in this case channel 1. We're not going to do anything with the marker since I have nothing connected to it on the front panel of the AWG. So just know that it's here. Pretty straightforward in its configuration. So now we're back to the carrier data. Here in these three tabs, we've got carrier data, channel settings, where we can set some general things for the channel, 0.75 for the upper limit, minus 750 millivolts for the lower limit. Both are permitted. We can actually invert the polarity here if we choose to do so, have some delay if needed, and then the baseline offset is set to 0. Load impedance is 50. This is a 50 ohm output impedance on the AWG connected to the oscilloscope, which is also set to 50 ohms, so we're matched there. The couple, these are actually coupling parameters. These couple the parameters from channel 1 to channel 2, and we can see those there. They're all unselected at the moment, and we're just generating on channel 2, so we're not going to do anything with these either. If they were selected, then we could do that. Right now the channels are uncoupled, but that would make them coupled. Okay, we will leave this one here, and then back to the carrier data. So I think I mentioned we're 100 megahertz, 1.2. plus or minus 600 millivolts, 0 degrees, and so forth. We've got the trigger button set to, or the trigger is set to the trigger button. Now, this is set to run mode continuous, which means that if I turn the channel on and go to the run mode, we were stopped, we're in the run mode, we should expect to be already generating that 100 megahertz sine wave. Let's go confirm. So that'll be on our oscilloscope. It's there. Let's go to full screen on this. Here we go. So that is our 100 megahertz sine wave, plus or minus 600 millivolts, just as we expected. We can turn on the parameters here, some measurement parameters that I had set up ahead of time. Here we go. This does confirm that we're very close to 100 megahertz. Amplitude is just a little less than 1.2 volts. Again, we're through about a 1 meter cable there, so we expect to lose a little bit of power through that cable. The pulse width, we'll look at the pulse width later as we go to the pulse generation. Right now, not so important. So that's what we expect to see. Let's go back to the AWG. And now let's look at some different run modes. Next run mode we'll look at is, here's our 4 choices: continuous, burst, modulated, or sweep. Modulated is amplitude modulated and sweep is frequency modulated. Burst mode next. And as we do that, then we go to the burst. As we select burst mode, then we get a tab here for burst data. That's where we're going to set this. And here the burst length is set to 100. Let's set this just to 1 cycle. There we go. And now let's go back to our scope and confirm that we are not generating. And we are. And for this, I want to wait for that 1 cycle to come through, so I'm going to set the trigger to single. We can turn our measurements off. Now notice that here we are waiting for the trigger, and as we trigger, we should generate a single burst right here in the middle. And let's just set ourselves sort of at the middle. There we go. So we expect our burst to be right there at the middle of the grid. Back to the AWG. And so before I do this, we want to see the trigger in action. So I'm going to take us out of full screen mode for the team viewer here. Better to set this one to begin with. I'll set this one there, which means that the team viewer for this one should be full screen here. Here we go. That's what I want. Okay, so displays are a little small, but we can see them both at the same time. Notice that we are waiting for the trigger here. And now with the trigger button, we will set the trigger. There we go. And there we see our 1 cycle, which is good. Next thing we can look at is we can look at n cycles. Not 100 in this case. Let's look at just 3, just so we can easily see that we're going to generate 3 cycles. I want to go to, well, auto, see that we're not generating, back to single, see that we're waiting for the trigger here, which we are, and then we send that. Now we should see 3 cycles. Now I missed the trigger button there. I want to turn channel 1 off, back to channel 2, and then we send the trigger. There we go. There's our 3 cycles. So the next run mode we want to look at now, I think we can go to full screen both. We saw the trigger in action, and that's what we wanted to see. Full screen on that team viewer. Full screen here. And now the next is infinite cycles. Now this is almost the same as the continuous, with one exception. It doesn't start to generate until we send the trigger. And we can confirm that. Let's go back to auto. And here, I'm going to go to a normal trigger. So once we trigger and we're generating, it will continue to trigger. Notice that we're not generating now, we're waiting for the trigger. Now I'll send the trigger here. Now we can see that we're generating continuous, but we didn't start to generate until we set the trigger. Okay, finally, there is a gated mode. And for the gated mode, it's going to be, we're going to change our trigger now. And we're going to change the trigger to timer based. Notice that we have three choices for trigger. One is a trigger in, which is an external trigger in. Then there's the timer and the trigger button. We want the timer in this case. Now the timer is set to go off every 50 microseconds. Enter. Notice we entered 50, but we got 4.9999976 because it needed to land on an even sample, and we're sampling it at 6.16 gigasamples per second. So we're just a little bit off of something that divides evenly into 50. So that's our timer. What do we expect? We expect that we're going to generate our waveform every 50 microseconds on the timer. So we're going to generate every 50 microseconds. However, we are in the gated mode here. Gated mode, and that means every 50 microseconds, but it's going to be high for 25 microseconds, low for 25 microseconds. And let's confirm. It should be generating now. And we'll go to a normal trigger. Should be generating as the channel is off here. Here we go. Now we're generating. Okay, so we need to look at more time. We need at least 100 microseconds or so. That gives us 100 microseconds. Let's go to a single trigger. Here we go. Let's see. Let's go just a little bit more so we can ensure that we've got that done. Another single trigger. Here we go. So this should be 25 microseconds on, 25 microseconds off, and so forth. Let's confirm. Oh, we just happen to have our cursors almost the right place to do two of those. And this should be pretty close to 50 microseconds now. Here we are. And we can confirm that that it's off for 25 microseconds and on for 25 microseconds. Okay, cursor's off. Back to an auto trigger. That's the gated mode. And so there we've covered all the run modes for the sine wave. The other waveforms are going to be similar. Let's now look at the pulse mode. And in this case, let's go to continuous. There we go. So now let's take a look here. We've got 100 megahertz for the frequency. What that means is that as we generate the pulses, that the time between pulses is going to be over 100 megahertz. So that's going to be 10 nanoseconds. 1 over 100 megahertz is 10 nanoseconds. So amplitude is 1.2, offset 0, phase is set to 0. Rising and falling edges are set to a minimum, right? That's our minimum, 400 picoseconds. If the pulse there is 10%, should be about 1 nanosecond. So we got 400 picoseconds on the rise, 200 picoseconds on the top, 400 picoseconds coming down. That's what this system can do. The fastest edge it can rise in this case. So, and then we should have 9 nanoseconds between pulses. 1 nanosecond, 9 nanoseconds is 10. So set to go continuous. So this is going to be a continuous set of pulses. Actually, let's not set to go continuous. Let's do a bursted. Let's do bursted. Let's look at our bursted data, not gated in this case, cycles, and let's set ourselves to go 100. This says that every 50 microseconds, remember, we're on a timer-based trigger, 50 microseconds, we're going to generate these 100 pulses, and we're going to generate them every 50 microseconds. Okay, we should be generating now, so let's go confirm. Here we go. So here's our 100 pulses every 50 microseconds, and we can see that is very close to 50 microseconds. We can put the cursors on there and confirm again. We'll just put it to the beginning. We've got many ways to make this measurement, but this gets us pretty closely, and we're very close to that 50 microseconds. So the trigger is happening here, happens at the beginning of every burst, which gives us 50 microseconds. Cursor's off. Now we can just get a better look at those pulses as we decrease our time. Here we go. Let's turn our measurement back on. And we can see that parameter 3 is with that level, which is right at 1 nanosecond. Parameter 4 is with that level also, but with a negative slope. So now we're measuring the width of this negative pulse here, and that's about 9 nanoseconds. Frequency again is 100 megahertz, and our amplitude is 1.2. So that's precisely what we wanted to see. Okay, next, right at about 20 minutes here. So now that we've done the pulse, let's now go to the arbitrary waveform. For the arbitrary waveform, we can go to the file system and pull a waveform off the file system and generate that. And so we do that. Let me go through the process here. I've got a single pulse here that I've loaded. I'm going to delete that, and then we'll reload it. So to do that, we're going to let's do one thing first. I want to see that. Well, we don't need to see what the file looks like. I can tell you. So we're going to import this. This is our single pulse that we're measuring. These files are very simple text files with a single column of numbers. And in this case, the single pulse is a lot of zeros followed by some ones, and then again zeros. We can see that. So there we've imported it. That's what the pulse looks like. The duration of that pulse then depends on the sample rate which we're generating and how many points are there. I haven't figured this out, but it's really close to the 1 nanosecond that we were before. It's a little bit less than a nanosecond. So now we've imported it. It's in our list. And so let's go back to the channel configuration here. And now we're in the arbitrary mode. And now we can generate our single pulse, which is here. This is the one we just imported, a single pulse. Now keep in mind, this could be any arbitrary wave that we could generate. It could be speech or something like this. This is a very simple example. Again, it's just a pulse. What's our burst? Burst length, 100. So we should be generating this now on the timer, and we can go confirm. And there's our pulses again on the timer. As I mentioned, we're just a little bit less than a nanosecond. This is like 900 picoseconds. However, the space between them is still 900, well, 9.1 almost. So we're still, time between here and here is still 10 nanoseconds. That we can confirm with a cursor. 10 nanoseconds or 1/100 microseconds. Need the relative cursors. trying to grab this on the right here. We'll put that right at the beginning of this pulse here. That at the beginning of that pulse. And then we should be pretty close to 10 nanoseconds, 9.95 nanoseconds. That confirms. With that, I think we conclude this video demonstration. We went through sine wave, pulse, and then the arbitrary wave. With the sine wave, we went into some detail to show all the different generation modes that we have. Two different types of triggers, the button trigger and then the timer trigger. Again, everything that went through is in this operator manual here for the T3AWG6K series. The other AWGs are very similar, but this is for the simple AFG, or for the simple arbitrary function generator. All right, so with this, we will conclude, and this wraps up this video. Thank you very much.